Well, thank you for joining me for part 2 of our wonderful lecture. If you can, please, or I don't know, did anyone start this without me? I'm wondering. But either way, we're in this together. So for letter B, I'm looking for the fourth root of, I have the fourth root of 2x divided by the fourth root of 3x squared. And this time, I'm not looking for perfect squares or cubes. I'm looking for perfect fourths. So the numerator, it just is what it is. I don't really care too much about that. It is simplified though, I do appreciate that. But in the denominator, what I have right now is 3 times x squared. Now, what do I need to multiply by in order to get perfect cubes? Perfect fourths. And whatever I multiply by, I'm going to do on the top and the bottom. So my goal, just to show you what my aim here, is to get 4 over 3 to the fourth and x to the fourth. Well, how do I get there? Well, right now I have 3. Great, there's only one of them, but I need 4 of them. So if I need 4, I need to multiply by what? 3 to the third, because 3 plus 1 gives me that fourth. What do you have to multiply x squared by in order to get x to the fourth, which is a perfect fourth root? Very good, x squared. So whatever I do to the denominator, I'm going to also do to the numerator. And then let's check myself. Fourth root of 3 times 3 cubed is 3 to the fourth. X squared times x squared is x to the fourth. My goal has been accomplished. Yay for us. My new numerator is the fourth root of 2 times 3 to the third power. 3 to the third power is 27. 27 times 2 is 54. I won't be mad if you check me on your calculator. And then x times x squared is x to the third power. Any perfect cubes? I'm stuck on the cubes. Any extra fourths? None. None right here at all. Yes, just kidding. In the denominator there are. So the numerator is 54 x cubed. Nothing I can do with that. The denominator, these cancel. And these cancel, so I just have 3x. There is no more radical in the denominator, so I am golden right now. Lovely. All right, simplify each expression, rationalize denominators, assume that all variables are positive. So the numerator for this one is 8. I'm not completely sure that I care. I'm also not sure why I like to rewrite every single problem in my own ink, but I'm doing it. So I'm looking for perfect cubes. Question is, what must I multiply by in order to get that? Numerator, I don't care. But the denominator, I have a 2. I have 2 to the first power. So I need to multiply it by 2 to the second power because 2 plus 1 gives me the third. Now I would have a perfect cube. And now I have x squared. If I have 2 already, I need there to be 3. So I need to add 1 more. 2 squared over x. Now what? Well, the numerator is just 8 times the cubed root of, well, what's 2 squared? 4 times x. The denominator is the cubed root of 2 times 2 squared is 2 to the third. X squared times x is x cubed. The denominator is, well, these cancel. So I have 2x, which is beautiful. The numerator, I didn't write this as 2 squared because it's not a perfect cube, so I don't really need it in exponential form. 2 squared, just the 4. I just wrote that like that. X. Love it? Yeah, I do, but we're not done just yet. Why? Well, because both of these are on the outside, and if you had 8 over 2, you would reduce that. 8 over 2, you would reduce that to 4, because 2 goes into 2 one time, 2 goes into 8 4 times. So I have 4 times the cubed root of 4x divided by, now this 2 is gone, so it's just x. 10. All right, one more for us. One more. What am I looking for? Perfect cubes. Am I? Not yet. First, I would kind of like to combine as much as I can, because sometimes that makes some of the things that I'm not really feeling go away. So let's make this under 1 cubed root. Well, let's see what we can simplify. There's nothing to go with this 25. Nothing at all. So I'm just going to leave that there on the bottom. But I do have an X and an X on the inside, so I can cancel that. So the X's are gone. They're ghost. I don't need to worry about those anymore. That's great. Glad we reduced. And then I have y to the 4th over y squared. I don't know, but I like to use my fingers as much as I can. So I have y to the 4th on top, and I have y squared on the bottom. I can subtract 2 y's from both the top. So 2 are gone and 2 are gone. What do I have left? I have y squared. Where's the y squared left at? Up top. Love it. Otherwise, you can just subtract 2. 4 minus 2, y squared. I find that I'm fine with this because I can see that it's just 5y squared. The bottom, it's the cubed root of 5 squared. I'm on the edge. I'm living on the edge over here. I'm looking for perfect cubes. So what will I do? Well, I'm going to multiply by the cubed root of something. Cubed root of something. Well, what? I only care about the denominator. The denominator is 5 squared. So what do I need to multiply by? Just a 5. So up top, I have the cubed root, 5 times the cubed root of. There's a 5 here. So I'm going to write that first. And then y squared is up there as well. And the denominator is the cubed root of 5 to the 3rd, because we had 5 squared times 5 is 5 to the 3rd. Beautiful. These are gone. I've rationalized the denominator so that all I have is 5 in the bottom. Up top, I have 5 times the cubed root of 5y squared. Am I done? Nope. I have 5 and 5. Let's cancel them out since they are both on the outside. Not going to cancel this out because it's inside of a radical. It's not the same. So I have the cubed root of 5y squared. There's absolutely more than one way to get to this correct answer. I am showing you what's most intuitive for me and what I think will give us the least mistakes in the long run. So thank you so much for joining me. I hope you had a great lesson. Goodbye from me and my wonderful Jamaican pencil. Y'all have a good day. Thanks.